Hi, Vicki Williams here. I'm going to do for you today Lab 9, mole ratios. Now the whole concept behind this lab is that substances will react in whole number ratios. And this reaction, I'm reacting an acid and a base. This reaction is exothermic. So when I have the right mix of chemicals, I will get the largest temperature change. So what I'm going to be doing is taking the unknown acid, and I'm going to be taking sodium hydroxide solution, freshly made today, and I'm going to mix different amounts. I'm going to do two things to make sure the data is meaningful. First of all, the total of the two amounts is always going to equal 60 milliliters. So however much sodium hydroxide I put in, the amount of the acid is based upon the amount of sodium hydroxide because they always have to add up to 60 milliliters. So when you look at the second page of the graph, which will have some dots, and it'll have one dot at the top, that dot is where the correct mole ratio was reacted. So we had the maximum temperature change. So I'd like to show you some of the equipment we're going to be using today. Sorry for Okay, I want to take you and show you the setup for this lab. First, I have a computer open to the LabPro program. I have a LabQuest Mini hooked up to the computer and to the temperature probe, which is right here off of the and there's the coffee cup calorimeter in a beaker. I'm going to add a stirring bar to that, and I'll show you how that works. You can see this little stir bar going around in there. That keeps our solutions mixed well. I have graduated cylinders labeled with base, and I have my base solution. I have a wastewater beaker to rinse off the temperature probe between experiments. And then I have my acid and my graduated cylinders labeled with acid. And then I have a waste container because I have to neutralize the acid and base before I can put them down the sink. Okay, so that was our setup. And I'm going to plug this computer back in so it can record things for me. The first ratio I'm going to test for you, I'm going to do 30 milliliters of each solution, and we'll see how high the temperature gets. Okay, the first thing I'm going to do is add the base to the cup and turn on the little stir bar so it's stirring. And I need to raise the temperature probe just a bit so it's not interfering with the stir bar. I'm going to press collect over here so we can get this temperature before there's a reaction. And I'm going to wait for the temperature to stabilize for a few readings. Looks pretty stable. Now I'm going to add the acid, and you should see a temperature change. And so you can see the temperature changes right away. And we'll go ahead and let that stabilize 32.5. So I'm going to do each of the ratios the same way as I've done this one. I just won't show you in detail the temperature change. It looks like 32.5 is our high temperature. I'm going to go ahead and stop. And then I'm going to go to the next page. Well, first of all, I have to analyze a little bit. So I want to get the statistics. So you see the minimum temperature was 27 degrees and the maximum temperature was 32.55. So that's a difference of 5.55 degrees. So I'm going to go on page 2 and I'm going to put in the volume of NaOH, which I use 30 milliliters, and I'm going to put in the temperature change, 5.55. And I'll do that after each ratio, and that way I'll have a graph by the time I finish. So now I'm going to get ready to do the second ratio. Okay, I'm ready for the second trial. This time I'm going to use 20 milliliters of NaOH and 40 milliliters of the unknown acid. This is trial 2, 20 milliliters of NaOH and 40 milliliters of the unknown acid.